Hello and welcome to part 1 of Debunking Creationist Geology. Today we'll cover flood legends around the world, erosion features, coal seams, and clams found on Mount Everest. Before we get started, we have some fair use issues to address. Specifically, I'm claiming Section 107 of the Digital Millennium Copyright Act, which covers contents and criticism. Today I'll be debunking Eric Hovind and his Creation Minute series. This should be pretty interesting, so let's get started.
Was there really a worldwide flood 4,400 years ago? Skeptics claim it's all a myth. However, there's overwhelming evidence that indicates the flood really occurred. More than 270 cultures around our world have a legend of the flood.
Just because there are numerous flood legends doesn't mean that it's fact. That's no different than saying Beowulf or Aesop's fables were truth just because they were written down. Similarly, just because my cat looks at the stars doesn't mean he's a cosmologist, or that the fact that he lays on my textbooks now and then doesn't qualify him to teach geology. I mean, your lack of critical thinking here is pretty much pathetic.
Geologists find massive erosion features all over the world.
You're exactly right. Geologists do find massive erosion features all over the world. That's because erosion has been going on for billions of years. However, you mentioned deserts, canyons, mountains, and icelands as being massive erosion features? Sorry, but that's just not the case. Although your father claims to have taught science for 15 years, it's clear that neither of you have an idea as to how science really works. Deserts, for example, are created by convection currents, which dry out the surrounding area and leave kind of a dense, lush area in between. This is why the African jungle is between the Sahara and Kalahari deserts. Similarly, if we move on to canyon erosion, it can be created by water, ice, or mechanical erosion caused by traveling sand and debris. If you look at mountain formation, for example, you've claimed that you've gone on several road trips with your dad. You just need to look at a road cut once in a while and you'll see where the land is actually folded. Folding creates synclines and anticlines, which basically lead to mountain formation. Nothing hard here. With glaciers, on the other hand, glaciers result from accumulations of snowfall that eventually freeze and get compacted in the ice. And when that happens, it builds up. It typically starts to slide down a hill face or a hillside and starts to erode things away. And now to address our next set of issues.
Coal seams span the entire globe, some of them hundreds of feet thick.
Okay, so you've discovered that coal seams can be really thick, but not all coal seams are. In fact, you can have multiple layers of coal seams on top of each other. Coal's formed when you have a swampy kind of area with a lot of vegetation, and the vegetation tends to collapse down and rot away. When this covers over with sediment and compresses down, you get some really interesting things that start to occur. First off, you have the formation of peat, which is kind of like an organic material that's about 60% carbon. As that compresses and heats up even more, it converts down into lignite and bituminous coal. When you compress this even more and add a bit more heat, you get anthracite. The majority of coal formed during the Carboniferous period, about 300 million years ago, and it spanned the entire globe because the continents hadn't yet broke up. If you'd learned anything about sedimentology, paleontology, or plate tectonics, you'd know this by now.
On top of Mount Everest, they even find clams. Now, when a clam dies, it relaxes and opens up. These are found in the closed position, 450 miles from the beach, and 5.5 miles above sea level.
Not all clams open up when they die. In fact, if you go to a decent seafood restaurant, they'll tell you that if a clam hasn't opened, you shouldn't eat it because it's spoiled. The reason you find clams on Mount Everest is because the rocks that make up Everest were once seafloor. You see, the continents ride on plates. These plates move around due to convection, which you can illustrate by looking at this oil heater or by boiling some water. The Indian plate slammed into the Eurasian plate, and when it did so, it started to push up the mountains. To make this even more apparent, I've highlighted the border of the Eurasian plate and the Indian plate. Notice the mountain ranges, which is exactly where you find Mount Everest.
The Grand Canyon, 277 miles long, 10 to 18 miles wide, and more than a mile deep. That's impressive. In the bottom is the Colorado River. You know, some scientists suggest the Colorado River formed the Grand Canyon over millions of years. The Colorado River exits the canyon 1,800 feet above sea level. It enters the canyon 2,800 feet above sea level, and the top of Grand Canyon is 7,000 feet above sea level. So you tell me, did the river flow uphill for millions of years to carve out the Grand Canyon?
Alright, so you think the Grand Canyon means there was a flood. So let's go ahead and start debunking this. About 35 million years ago, there was an uplift event that more or less cut off the Colorado River as we know it today. This was basically the origin of the Kaibab Plateau. When this uplift occurred, it forced the Colorado River to go southeast to the Gulf of Mexico instead of the Pacific Ocean. The old course ended up draining the Kaibab Plateau into the Hualapi drainage system, which still drains major portions of the West today. At some point around 12 million years ago, the river's course to the Gulf of Mexico became blocked, possibly by another uplift event. An enormous lake referred to as Lake Bidahaki was formed as a result. Meanwhile, on the western side of the Kaibab Plateau, a process known as headwater erosion began eating through the southern portion of the plateau, and after a few million years, the erosional process allowed the Hualapi system to break through the barrier created by the uplifted plateau and rejoin its original path on the ancestral Colorado River. Once the breakthrough was complete, the ancestral Colorado River began the new course because of its steeper and more desirable descent. The waters of Lake Bidahaki began to drain through the new course as well, and the result is the gorge in which the Little Colorado River now flows. The area once occupied by the lake became the Little Colorado River drainage system. It's also worth noting that the uplift is still occurring at about 1 centimeter a year, which is about the same rate at which the Colorado River is cutting down into the bedrock.
So was there really a worldwide flood? The evidence says
No, you crazy Dutch bastard.